All right, in this video, we're going to be talking about compound interest, compound continuous interest, as well as simple interest. So we're going to be talking about all three of these formulas. Now, we're going to go ahead and knock out the formulas and what they are. So compound interest, here you go, and you might need to pause the video so you can write all this stuff down. Now, what all the letters stand for is this right here. Principal, percent as a decimal, you're going to have to write that down. Now, the one thing that might be a little confusing is what this E is in the continuous formula, what this I is in this continuous formula, and we'll talk about that as we're working through it. And lastly, and this is what we're going to start with first, is what the N equals. All right, so N equals the number of times interest is compounded, and we'll talk about that in a second. So let's move on. All right, so number of times. Now this chart here represents what N can be. I'm going to put that in quotations, what N can be. So I'm going to start with an easy one, daily. How many days are there in a year? 365. All right. How many quarters are there in a year? 4. Semi-annually, that means 2. And annually, how many years are there in a year? 1. Now, the one thing that we should put on there is monthly. And I don't know why we didn't, but and remember, writing with my mouse here is 12. All right. Now, not to oversimplify this, but a lot of this stuff is just plug into your calculator and press enter. All right, so Marie deposits $1,650 for 3 years at 3% interest, compounded daily. What is her balance? Now, when you hear the word compounded and then daily, those words, it's going to be this formula right here, the big formula, okay? Because that is the only one where N comes into play, which in this case is going to be daily. So here's how you'd set it up. It'd be 1650, parenthesis 1 plus, remember, R03 as a decimal over. Now, N, since it's compounded daily, will be 365. Raised to the power of 365 times, let's see, 3 years. So that would be 365 times 3. So you're going to throw this into your calculator, and then you are going to get your correct answer. $1,805.38. That would be your final answer. Now, let's go down to this one. Jimmy invests $4,000 in an account that pays 5% annual interest. Here we go. Compounded semi-annually. What is his balance to the nearest tenth or the nearest cent? Now, I'm going to pause the video and I'm going to set the problem up. Semi-annually means I'm using, once again, the big formula. All right, so I'm going to pause the video and put all this into a formula. All right, 4,001 plus 0.05 over 2. Remember, 2 represents what N is. I'm going to press enter on my calculator, $6,554.47. Now remember, this is kind of like the highlights of all the lessons. It's hard to get all the information in these videos. This just kind of gives you an idea of where we're at. All right, now let's go to the next formula. The next formula is compounded continuous. Now this is the buzzword that you need to pay attention to. Compounded continuously or continuous. All right, whenever you see the word continuous or continuously, you're always going to be dealing with this formula here. So let's do an example. I believe it's this example here. Here we go. If you deposit $1,000 at 4.3% interest compounded continuously, what would your ending balance be to the nearest cent after 5 years? Well, we're going to use this formula again. It is that right there. So it is going to be 1,000 parenthesis. Ooh, I think I messed that up. All right, sorry, it's not 1,000. It is 1,000. Sorry, forgot to put the E on there. 1,000 E, and it is going to be 0.043 as an exponent times 5. Now, E is actually a function on your graphing calculator. All right, E is actually a function on your graphing calculator, and so you would literally type this into your graphing calculator and just press enter. And when you do that, you're going to get an answer of $1,239.86. So $1,000 put into an account after 5 years ends up being $1,239.86. Let's try another one. Now remember, I'm going through this relatively quickly because most of this is just using formulas. Up here we go, number 7. Find the interest earned on $30,000 deposited for 6 months at 4% interest, compounded, here we go, continuously. All right, so compounding continuously, that's where I'm going to use my E. So 30,000, remember writing with my mouse here, 4.5% will be 0.045. Now this is where it gets tricky. Let me go back to the formula here. T represents years. All right, T represents years. So going back to question number 7, it says for 6 months. They're trying to trick you. 6 months is not a full year. In fact, 6 months is half of a year. So we would multiply that by 0.5. That's what's going to trick a lot of students. All right, because they're going to want to put in 6 in for that, but it's not 6. If you put in 6, you're saying 6 years at 6 months. So that would have to be 0.5. So when I type all this into my calculator, my answer ends up being $30,682.65. Not bad after just 6 months. Now, actually, the question is find the interest earned. So finding the interest earned, if you started off with 30,000 and you end up with 682 or 30,682, basically it just says find the interest earned. It's just find the difference between the two. So let me scratch out this 30 because I would be subtracting. So I made $682.65 in 6 months. All right, the last one that we're going to run over or run into, whatever, is going to be simple interest. So simple interest, you notice that we have PRT, which PRT is the same. I represents how much interest you're going to make. All right, so you're going to see an example of this in 1 second. All right, for example, number 5. Find the simple interest on $2,350 principal deposited for 6 years at a rate of 4.77. So we're just going to use our simple interest formula. So $2,350 times the percentage, remember, as a decimal, move your decimal 2 over, times 6 gives me $672.57. Now, let me show you real quick. This is where the simple interest gets different, is different from everything else. When you're dealing with the compound interest questions, this problem right here, this tells you how much money is in the account after, what was this, after 3 years. After 3 years is $1,805. Now, this is where it's different. For the simple interest, it just tells you how much money it made. So if you were to ask another question, okay, how much money is now in the account? You would take your initial principal, which is this, and add it to this, and this will tell you how much money is now in the account. So $672.57 just tells you how much money was made. All right, so like for example, let me see if I can do the one. All right, let's do question number 6. It looks pretty simple. So $2,560 dollars at a rate of 5 1/8%. So 5 1/8% is 5.125. So I'm going to multiply that, big dot multiply, 0.05125. Remember writing with my mouse. Times, here we go, 17 months. Well, in the formula, time is years, 17 months. Well, we know that there's 12 months in a year, so I'm going to multiply that by 17 over 12. 17 divided by 12, that's more than a year. So when I get all this information in, let me clean this up a little bit, get that out of the way. So I end up with an answer of, let's see, $185.87. Okay. So how much simple interest did we find? It was $185.87. But if the question said how much is now in the account, then once again we would take 2,560 and we would add it to our simple interest to figure out how much is in the account. Okay, so that's the difference between the interest formula. Let me see if I can go back to it real quick. So that is the difference between the simple interest formula, which is right here, as well as the two compounded interest formulas. All right, so if you have any questions, let me know. Thank you for watching.